Okay, for 3A, we're doing a derivative. I'm going to differentiate this right here. So this problem is going to have a couple different pieces to it that are going to kind of go over a few different types of differentiation formulas that you would do for each one. So pretty much each of these are going to require a different type of derivative. The first one's a power rule. We have a trig here, and then we have a natural log one over there. All right, so let's start with this. This here is the same thing as 5 over 2. It's always the inside power divided by the outside 1. So when I take the derivative, technically I have x to the 5 halves. So 5 halves is going to come down, x, subtract 1 from that. It was 5 halves, so we subtract 1 from that, it's 3 halves. Okay, so we get that right there. That's going to be that one. Now next thing that we're going to do is do the cosecant. Now cosecant, the derivative of cosecant is negative cosecant cotangent, so because there's a minus sign there, it's going to turn into a plus. So we're going to do plus cosecant cotangent. This one is a natural log, so that requires the u primed over u formula. So for that one, we're going to be doing the u goes in the bottom, that's the 4x. The derivative of 4x goes on top, which is a 4. So those are going to end up canceling out. And so then basically your answer is going to be the same thing that you have. Now this, if you want to write it as a root, you can. So the way that works again is basically going to be the square root of x cubed. So if you want to write it as a root, you can, not necessary. Plus cosecant cotangent. The 4's cancel out here, and then you get 1 over x. A question that comes up is, do we have a plus c on this one? I said no, the answer is not going to be plus c because this is a derivative. The plus c is only for the indefinite intervals. So because you're taking the derivative, you don't need a plus c on the end on your answer.